Hello my dear friends, how are you all? I hope you all are fine. So my dear friends, you are very welcome in our lecture number 2, some application of trigonometry. Okay, so my dear friends, I hope you will enjoy this lecture. Okay, so without wasting the time, let's start. Yes, so today we are going to discuss heights and distance. Okay, and in previous lecture we will learnt about the introduction of application of trigonometry. Okay, and in this case, in this lecture, we are going to discuss one of the most important application, heights and distance. So this is the application of trigonometry. Okay, so the topic so the topic heights and distances. So this topic heights and distances is one of the most important application of trigonometry. Okay, is one of the most important topic of trigonometry. It is most important topic of trigonometry, which is extensively used in real life. So so in this, so the word so the words heights and distances heights and distance are frequently used in trigonometry frequently used in trigonometry. Okay, my dear friends, so these heights and distances, so these words are very common in trigonometry while dealing with its application. While dealing with its applications. Okay, my dear friend, so in the heights and distances application of trigonometry, the following concepts are included. Okay, so what are these? So first is measuring the heights of towers or big mountains. Measuring the heights of towers or big mountains. Okay, my dear friends, and second is determining the distance of the shore from the sea. Determining the distance determining the distance of the shore from the sea. Okay, my dear friends, and the last is third is finding the distance between two celestial bodies. Okay, my dear friends, so I hope you get this point. So it should be noted that finding the heights of bodies and distances between two objects is one of the most important application of trigonometry. So we can say that finding the height and distances of bodies between two objects is one of the most important applications of trigonometry. Okay, my dear friends, so I hope you get this point. So my dear friends, I hope you understand the thing that the heights and distance is one of the most important application of trigonometry. Yes, so now we are going to discuss some important definitions. Okay, some important definition. Okay, so the most important, most significant definition that are used when dealing with height and distances are given as: first is line of sight. So first definition is line of sight. What is line of sight? Okay, so the line which is drawn from the eyes of the observer, okay, of the observer to the point being viewed on the object is known as the line of sight. Is known as the what? Line of sight. Let's suppose we have a object. Okay, so what is line of sight? So the line which is drawn from the eyes, okay, of the observer to the point being viewed on the object is known as the line of sight. Okay, so what is line of sight? So the line which drawn from the eyes of the observer means, let's suppose we have a tower like this. This is a tower and there is an observer is standing here. Okay, so this observer, from the eyes of this observer to the top of the tower, okay, so this line, so this distance is known as what? Is known as line of sight. Means LOS, line of sight. Okay, understand what is line of sight? So the line of sight is drawn from the eyes of the observer to the point being viewed on the object. Means what? Means when we draw from the eyes of the observer to that point, which point is being viewed on the other object. Okay, so that's the line is called line of sight. So my dear friends, I hope you understand that line of sight. Okay, so now let's move on. So the next definition is second is angle of elevation. What is angle of elevation. What is angle of elevation? Okay, so the angle of elevation of a point on the object above horizontal line viewed by the observer is the angle which is formed by the line of sight with the horizontal level. With the what? Horizontal level. Okay, so the angle of elevation, the angle of elevation of the point on the object above horizontal line viewed by the observer is the angle which is formed by the line of sight with the horizontal level, means, let's suppose again we have a pole or tower. This is base, we have a pole. Okay, now let's suppose we have an observer. Now if this is a line of sight, okay, if this is a line of sight, so the angle of elevation of a point on the object, okay, above the horizontal line, okay, viewed by the observer is the angle which is formed by the line of sight. Means this is our LOS, line of sight, and this is our horizontal level. This is our horizontal level. So the angle between LOS and horizontal level is known as what? Is known as AOE. Means AOE. Means what? Means angle of elevation. Angle of elevation. Understand, my dear friends? So this is the angle of elevation. Okay, so now, so the next definition is angle of depression. What is? Third definition is angle of depression. So what is angle of depression? The angle of depression of a point on the object below horizontal level viewed by the observer is the angle which is formed by the line of sight with the horizontal level. Means it is saying that the angle of depression on the of, here is of the point, here is of the point on the object here is the main concept is below the horizontal level, below horizontal level. below horizontal level. Okay, viewed by the observer is the angle which is formed by the line of sight with the horizontal level. So here horizontal level. So my dear friends, here is the difference is this: below horizontal level and in line of sight. What is the concept? In line of sight is above horizontal line, means above horizontal level. Okay, understand? So let's suppose this is a ground. This is what? This is a ground. This is our ground. Okay, now there is a building. This is a building. Now someone is standing here. Our observer is standing here, and he is viewed on the ground. There is an object like this. This is object. This is our object. Now someone is standing here and try to see this object. Like this. Yes. Okay. So this is our what? This is our line of sight. This is our LOS, line of sight. Okay. Now listen to me very carefully. This is horizontal level. Horizontal level is always concerned from their eyes, from the observer's eyes. Okay, and this is what? Yeah, this is horizontal level. Okay, so what is the angle of depression? So the angle of depression of the point on the object below horizontal level, means below horizontal level, viewed by the observer is the angle which is formed by the line of sight with the horizontal level. Means this angle is what? This angle is AOD, means angle of depression. So my dear friends, I hope you understand these points. So the difference between angle of depression and angle of elevation is that in angle of elevation, the observer is looking upward, and in angle of depression, the observer is looking downward. So that's the difference. Okay. So my dear friends, I hope you understand this concept. So now let's move on. Okay, so now let's move on. Yes. How to find heights and distances. Okay. So now, my dear friends, in this case, okay, so to measure heights and distances, the different objects we use trigonometric ratios. Okay, so to measure the heights and distances of different objects, we use what? We use trigonometric ratios. For example, in this figure, if we see that in this figure, a guy is looking at the top of this lamp post. Okay, let's suppose this is our lamp post. Okay, and AB is our AB. This AB is our horizontal line. Is our horizontal line, which is parallel to the ground, passing through the observer's eyes. This is always passing through the observer's eyes. Horizontal line is always passing through the observer's eyes and parallel to the ground. Okay, my dear friends, and there is a line AC, which is known as line of sight, and the angle between line of sight and horizontal level is angle of elevation. What is? Yes, angle of elevation. So similarly in this figure we have PQ, which is line of sight, because the observer, this is our observer, is looking downward to this object. Okay, so a line of sight like this, and this is our horizontal level. This is our what? This is our horizontal level, and the angle made between them, the angle is below the horizontal level. The angle is what? Below the horizontal level. Okay, and this is the angle of depression. Now the method to find the heights and distances is that if we know the line of sight, okay, and if we know this angle, okay, and we know that this is 90 degree, so with the help of trigonometric ratios, with the help of what? So to measure heights and distances of different objects, we use what? Trigonometric ratios. Okay, so let's suppose we know that this is our perpendicular, and this is our hypotenuse. This is perpendicular, this is base, this is hypotenuse. So with the help of trigonometric ratios, like we know that sine of A, okay, is equals to, we know what is perpendicular upon hypotenuse. And if you want to know the distance is perpendicular, if you want to distance is this, okay, so we can put the values of sine A and hypotenuse, which is our line of sight, okay, and we can easily find the value of P. Okay, same in this case, this is our right angle triangle, this is our angle, this is our what? Hypotenuse, this is our perpendicular, and this is our base. Okay, my dear friends, so I hope you understand these things, how to find the heights and distances. This is our height and this is our distance. In this case, this is our height and this is our what? This is our distance. Okay, so this is the most important thing. Okay, yes. So now, my dear friends, so the angle of elevation and depressions are usually measured by the device called inclinometer or clinometer. This is a device which is known as inclinometer or clinometer. Okay, so my dear friends, with the help of this device, we can easily find the angle of elevation and angle of depression. Okay, so in this device there is a term which is eyepiece, and this is protector. This is what? This is protector. This is the main measuring device, protector. Okay, so my dear friends, I hope you understand these things. So let's move on. So my dear friends, to solve heights and distances problem, Okay, to solve height and distance problems, trigonometric ratios of standard angles are used. Okay, so to solve heights and distance problems, we have to use the trigonometric ratios of standard angles. Okay, we have to use trigonometric ratios of angles. Okay, so what is the table? So now let's draw the table. Okay, so now we know that here is theta. Okay, so this is 0 degree, this is 30 degree, this is 45 degree, this is 60 degree, and this is 90 degree. So in previous lecture I already told you that how to generate this table. Okay, so this was the very easiest method. Now here I am going to put the direct values. Okay, so here is the ratios: sin theta, cos theta, tan theta, cosec theta, sec theta, and cot theta. Okay, so now we are putting the values. What are the values? Yes, so this is the table, and with the help of this table we can easily find the heights and distance with the help of this table. Okay, yes, so what is the value of sin 0? It is 0. What is the value of sin 30? It is 1 by 2. What is the value of sin 45? It is 1 upon under root 2. What is the value of sin 60? Which is root 3 upon 2. And sin 90 is 1. So you have to be learn just only one angle, one ratio, sin ratio, and you can find rest of the ratio with the help of sin ratio. So what is cos theta? So now we have to reverse this. So 1 root 3 upon 2, 1 upon root 2, 1 upon 2, and 0. Tan theta is sin theta upon cos theta, means 0, 1 upon root 3, 1, root 3, and infinity. Okay, cosec theta is the inverse of sin theta, means this is infinity, this is 2, this is root 2, this is 2 upon root 3, and this is 1. Sec theta is the inverse of cos theta. Okay, means it is 1, it is 2 upon root 3, it is root 2, it is 2, and it is infinity. Okay, and cot theta is the inverse of tan theta, means it is infinity, means not defined. This is root 3, this is 1, this is 1 upon root 3, and this is 0. Okay, my dear friends, I hope you get this point. So now let's move on. Yes, now heights and distances formulas. So now in this we can see three different cases when solving heights and distance questions. Okay, so the case 1 is, now in this case we can find, in this case we can observe we can observe what? First is height of a tower, height of a tower, hill or building, okay, or building, and distance of an object from the foot of a tower, from and distance of an object, distance of an object from the foot of the tower or hill or building, and sometimes shadow of them, sometimes shadow of them, okay my dear friends. And the third is angle of elevation or angle of depression, angle of elevation or angle of depression, okay my dear friend. So any two of the above three parameters will be provided in the question, okay, and the third one is we have to find, okay. So this type of problem can be solved using the formula as, now let's suppose we have a triangle like this, let's suppose this is right angle triangle, okay, this is right angle triangle A B C, this is our perpendicular, this is our right angle, and this line is perpendicular, this is our hypotenuse, and this is our base, and this is angle theta, okay my dear friend. So now we can solve the problem with the help of these ratios, like sin theta is equals to, we know that it is perpendicular hypotenuse, means AC upon AB, okay. Cos theta, we know that what is cos theta, cos theta is base upon hypotenuse, means BC upon AC. And tan theta, and what is tan theta, perpendicular upon base, and what is perpendicular, AC upon BC. So with the help of these ratios we can easily find height and distances, okay, or we can easily find angle of elevation, or we can easily find angle of depression, okay my dear friends. I hope you get this point. So now let's move on. Yes, now so the second case is, case second is, in this case we can deal with different illustrations, means one of the commonly solved problems is about the movement of an observer, is what, about the movement of an observer, okay. In this case we can solve, in this case we can solve one of the commonly solved problems, one of the commonly solved problems is about the movement of an observer, okay my dear friend. If the observer moves towards the object like a tower, building, hills, etc., then the angle of elevation increases, then the angle of elevation is what, increases, and the angle of elevation decreases when the observer move away from the object. Okay, so we can write it as if the observer moves towards the object, moves towards the object, okay, like a tower, building, or hills, etc., then the angle of elevation increases. Okay, and the angle of elevation decreases, listen to me very carefully, decreases when the observer moves away from the object, Okay, my dear friends, so here the distance moved by the observer can be found using the formula like, let's suppose we have a right angle triangle, okay, like this. Okay, we have A, B, and there is a point like this. This is point C and this is point D. Okay, so in this right angle triangle, D is a distance. This D is the distance between C and D. Okay, is the distance between C and D. This is angle X and this is angle Y and this is height H. Okay, my dear friends, so we can find the distance by the formula like this: D is equals to H into cot X minus cot Y. So with the help of this we can find the distance between D and C. Okay, my dear friends, so the derivation of this formula we will see in the further lectures. Okay, my dear friends, so I hope you understand these type of concept. So now let's see the another case, which is case number 3. So what is case number 3? So there is another case where two different situations happening at the same. Okay, so in this case we get similar triangles with the same angle of elevation or angle of depression. So these type of problems can be solved with the help of the formula related to similar triangles. So in this case we get similar triangles with the same angle of elevation or angle of depression. Okay, because because there are two different situations, because there are two different situation, different situation which is happening at the same time, happening at the same. Okay, so my dear friends, these type of problems can be solved with the help of formulas related to similar triangle. For example, let's suppose we have a triangle like this. Okay, and again this is a partition. So this is A, B, C, and this is E, D. Okay, and this triangle here is triangle ABC and triangle EDC are what? Are similar. Are what? Are similar. Okay, so by using basic proportionality theorem, we can write it as AB upon ED is equals to BC upon DC. BC upon DC. So this formula we can use by finding the heights and distances. So these cases, these three formulas are used to solve majority of the heights and distance problems. Apart from these cases, there are some other types of constructions could be drawn based on the given scenario. Okay, however, the combination of these formulas are used to solve any given problem related to the heights and distances in the trigonometry. Okay, my dear friend, so I hope you understand these cases. So now, so let's do some questions. Okay, so now question number first is, an aeroplane is flying at meters. An aeroplane is flying at meters above the ground. Okay, so the distance between the ground and aeroplane is h. So at a particular instant, the angle of elevation of the plane from the eyes of a boy sitting on the ground is 60 degree. Sitting on the ground is 60 degree. After some times, the angle of elevation changed to 30 degree. After some time, angle of elevation is changed to 30 degree. So find the distance covered by the plane during that time, assuming it travels in a straight line. It travels in a straight line. So this scenario is like as, let's suppose this is a ground. Okay, this is ground, this is point O. Okay, now here is the observer. Okay, here is the observer. Okay, my dear friends, so there is a plane like this. This is a plane. Now when the observer see at a particular instant, so that the angle is 60 degree. Okay, and after some times, this plane moves at this distance, and this plane goes here, and then the angle of elevation will become what? 30 degree. Will become 30 degree. Okay, so this is our first distance and this is the second distance. So this point, this is perpendicular. These are perpendicular. So this point is A, this point is B, this is C, and this is D. And this distance is what? H. Okay, I hope you get this point. And this distance is X and this is Y. Okay, my dear friends, I hope you understand these things. So now in triangle OAB, means O, A and B, in this triangle, in triangle OAB tan 60 degree. We are applying the formula tan 60 degree. What is tan? Tan theta is, we know that, perpendicular upon base, and perpendicular is AB and base is OA. So we can written as AB upon OA. Okay. Now we know that tan 60 is root 3 and the value of AB is h and OA is x. OA is what? OA is, we are assuming that OA is x. Okay. So the value of x is h upon root 3. Okay. H upon root 3. Now in triangle OCD, in what? In triangle OC and D, we are applying tan ratio same. So tan 30 degree is equals to DC upon OD. Okay. And what is tan 30? Tan 30 is 1 upon root 3. Okay, which is equals to DC is our h and OD is x plus y. OD is what? X plus y. So x plus y is equals to root 3h, is equals to what? Root 3h. Okay. So distance traveled by plane is y. Okay. Distance traveled by plane is y. Okay. So if we put the value of x is equals to h upon root 3 in above equation, then we get h upon root 3 plus y is equals to root 3h. So we get y is equals to root 3h minus h upon root 3. So from this we get y is equals to 2 upon root 3h. 2 upon root 3h. So if the aeroplane is flying h meters above the ground, it would travel for 2 upon root 3h meter as the angle of elevation changes from 60 to 30 degree. Okay. So when the angle of elevation changes from 60 to 30 degree, then the distance is covered by the plane is what? Is 2 upon root 3h. This is the distance is covered by the plane. So my dear friends, I hope you understand these things. So now this is enough for today, and we will meet in the next lecture. So thank you very much guys. Okay.